P.S. I was pulling up for AB. You guys know how all the free response are online, right? And I was pulling up, not an integration as net change, I was pulling up a graph of a derivative that had geometric areas. You could actually like integrate by finding the areas of the geometric shapes for whatever, displacement or maximums, minimums, etc. So I was having them play with an FRQ after the last test, showing them the answer key, showing them, you guys know how there are the student solutions like we did with L'Hôpital's. Like you can see like a 9 out of 9, a 6 out of 9, a 4 out of 9, 3 out of 9, high, middle, low. And of course the low is for all the poor kids that got 0 out of 9. Which having graded enough mock exams, 0 out of 9 can be a kid that didn't put anything. It can be a kid that wrote a whole nice short story or a picture for you. Or it can be a kid that did lots of math and lost all their points by putting wrong stuff in there. Some of you guys have been there, and it's a struggle. Some of you guys, your FRQs last year when you got it back and saw like 4 out of 54, you were like, oh. Or 1 out of 54. Or 0 out of 54. But that's not this year. But I was trying to show them what the AP answer key would show versus what the kid showed, and how like some of it was similar, some of it the kid did better, some of it the kid just expounded where he didn't need to. Trying to get them to get the idea between, or the difference between increasing, decreasing, and positive and negative, and how they're not the same, but how we have to have subjects to each of our sentences, not pronouns, not it. Or if you want to personify the curve, not he, but F or F prime or F double prime, or she. I guess you can call a curve a she if you want. Maybe it makes more sense. Anyway, coming back. So, the student that got a 9 out of 9 kept on saying, this hints that. I really hated that wording. He kept on saying, this hints, like F prime is increasing, and then this hints that F is concave up. And I'm like, hints at? Ugh. Don't say hints at in an FRQ. Say indicates. At least sounds smart. Hints at. I don't know, because hints at means like, oh, maybe. Oh, dear. Anyway, but he got a 9 out of 9, so they were very gracious. But hints at? Anyway, it was random. I thought you guys would be a little entertained. I was like, hints at? Really? Indicates? This seems to indicate? I don't know. Seems even sounds like the hinting thing. Anyway, so I used to think of this as being like a little, yeah, it's good. You'll see it every now and then. But then when I found the parting C, guess what T stands for? Telescoping. I wonder why this is called telescoping. Have you guys figured it out yet? Kind of. But why are you only looking at little small sections? Because you're not. You're looking at the whole thing. But why does the whole thing get summarized down into, ooh, this makes me think of MVT and the proof to MV. No, seriously? Okay.
Yeah, no, Miss C, take your notes. We'll go outside.
So I can cross these off because we just did this. Ha ha ha. So we can say this is going to a b sub n minus a b sub n plus 1. There we go. So now does this make sense? In that, look at the conclusion. The nth partial sum, well, I'll highlight what is. The nth partial sum would technically be b sub 1 minus b sub n plus 1. And so this will keep converging as long as this converges. So b sub n has to approach a finite number as n approaches infinity. Now, the reason I don't totally like this is a forever card is that I don't want you guys to get stuck on the b sub n versus the b sub n plus 1. It really depends on the telescoping series because they show up in many different ways. Like some of them will have like a b sub 1 minus a b sub 2 plus a b sub 3 minus a b sub 4. Like they might have some terms that stick around and they start canceling out. Like it really does depend on the series. So it's not so much I want you guys to have memorized the entire idea. It's more like, hey, if we can figure out the nth partial sum, then we can take the limit as n goes to infinity. You guys know what I mean. And basically, as long as this exists, I'm golden. So telescoping is unique because we might be able to actually get a formula pretty quickly because things start canceling out of the partial sum, take the limit to infinity, which if the limit of the partial sums converge, I'm good. It converges. And it doesn't just converge, it converges. That is. Sure, we'll make it a forever, but it's not one like on the Big Forever Endeavor quiz at the end of chapter 9 of all the tests. I'm not necessarily going to have you fill in anything much. I think the most important thing that I want is for you guys to have the nth partial sum converging or not that converging. The expression for the infinite sum, there we go. That could converge or could diverge. And kind of what Maggie asked out there that some of you might have heard and some of you might not. She's like, oh, well, we don't know what it's converging to. Correction. Geometric and telescoping, we can. If they converge, we know what they converge to, or we can find it. And so some of you guys, like, what does this look like? Let's have some examples. Sound good? So, this guy. Hey, it's the one I wrote up there. Which technically, this could have come from, because I'm warning you, it probably won't show up like this. Because this, you already have a clue of, wait a minute, if I keep doing this, maybe, it's probably going to show up instead as a nice little n squared plus n. What would my common denominators be? N plus 1 minus n, so the n's cancel, plus 1. There we go. It would show up like this instead. And so some of you might go the integral test because you're like, oh, I can do the integral. And technically, you're right. All the terms would be positive. Would they be decreasing? Would be positive and decreasing. And what you would see if you didn't do the partial fractions is you would see 1/2 plus 1/6 plus 1/12. Is that right? That's what you would see. You wouldn't see the telescoping. You only see the telescoping if it's split up into partial fractions. So then we could go ahead and say telescoping series will converge to, and I'll come back to that, since the limit as n goes to infinity of s sub n equals the limit as n goes to infinity of, what was the first term? 1. Everything's going to cancel out, minus. Why did I use 1 over n plus 1? So if I was to keep going, I would get 1 over n minus 1 over n plus 1. This 1 over n will have canceled with everything prior. At any nth spot, this is what's left. So as I keep on going, as I keep on going, as I keep on going, this guy goes to 0. 1 minus 0 is 1. Is that okay? So is it possible to have a telescoping series that's growing? I guess so. I mean, I guess you could have n minus n plus 1. Which just ends up canceling out and becoming 1, which will diverge because of the nth term test. Anyway, it's possible, but you don't see it very often. Telescoping series is almost always going to be used when you have a convergent sequence and to show why it's convergent. So what about this guy? Wait, pause. Nth term test. Nope, limit 0. We know nothing. Geometric. Nothing's to the n. There's no way it's geometric. P series? Nope. Direct comparison? I don't know if we can help it after yesterday. So then, can't we rewrite this to be partial fractions? Maybe with the hope. Okay, maybe you would do integral test. But even if you did integral test, wouldn't you have to do partial fractions? How else do you integrate that? Right? We'd have to do partial fractions. How do we do it? Yeah, heavy side cover up, right? P.S. Honors pre-cal. If you want some easy tutoring hours, just finish partial fractions. They're going to have a test on it soon. That's a good idea. You can do regular pre-calc and another vector test soon.
Okay, nope.
Okay, cover up 0, right? Cover up 0. 2 over -2, -1, yeah? Cover up 2, 2 over 2 is 1. Sweet. Wait, is this telescope? Start expanding it, yeah? So you have -1/3 plus 1 plus -1/4 plus -1/5 plus, oh, I told you not all telescoping work the same way. No, just keep going though. See it? It's starting to telescope, just took a while. If we were to keep going, okay, for our nth partial sum, we have to figure out what's going on. So what's going on? The -1/3 doesn't end up canceling until here. Finally, it's caught up. So is the -1/4 going to cancel? Yeah. Is the -5 one going to cancel? Yeah. Wait, when I was canceling, where was I canceling from? Does this guy cancel first? Didn't the second one cancel? Who was left every time? I've canceled with a prior. Who's still there? So therefore I can say S sub n. Wait, who got left behind? Who else got left behind? Do you guys agree? Wherever we stop, the second guy will have canceled. The 1 and the 1/2 are going to forever be there. And that -1/n is waiting to get canceled somewhere down the line. So then will this telescoping series, which it does telescope but in a really awkward, not nice and smooth way. It's like more like a one of those coming together. Like a slinky that's all messed up and you're trying to get it back. Will it converge? Yeah. Because the telescoping series will converge to the limit as n goes to infinity of S sub n. Or you could say since, I suppose. We'll figure out what the 2 is in a second. What do we have? 3/2. Wait, no. The limit isn't 0. Lo siento. That's going to go to 0, right? But do you see how not every telescoping... Yeah. It's not even really a test, to be honest. It's more of a, every series will converge if its nth partial sum converges. But it's usually way too hard, if not impossible, to find the nth partial sum formula, except for arithmetic, geometric. Arithmetic almost all diverge because they just keep adding. Geometric can converge because of the ratio of its between 1 and -1. Arithmetic has a formula for S sub n, geometric has a formula for S sub n, and telescoping, you can find a formula for S sub n. Everybody else is like, I don't know what the S sub n is, so let's do it with the tests. So in a way, yes, it's a test. In a way, it's more of just like a, oh, telescoping, yay, I can do his S sub n. Let me take a limit. Kind of makes sense? But what was the title of this section anyway, guys? So what are we comparing? I don't know, but it showed up in this section. So that's not really the other test. This guy is. So we had endeavor card number 17. Telescoping was endeavor card number, I didn't write it, I'm sorry. Endeavor number 18. In a way, it's a test. He is imparting C because he is nice and special, and he does save us from having to do the improper integrals. So technically, probably every telescoping could be, probably could be an integral test. Just saves a little bit of time if you see it. But the other comparison, it's direct and limit. And guess what? Limit is so much nicer than direct. However, if you guys notice, he has a lot of different pieces to him. Still, we're only dealing with positive terms. We're not dealing with negative or alternating. Alternating, parting C, PA, alternating. It's still limit comparison test. Just like direct, we still have to only have positive terms. Such that we're taking the limit of A over B. Now check it. It might be helpful to write given test. Sometimes I think it's a little bit tricky because it's like, oh, there are two. Okay, whoever, whatever. No. When you come down here, it says if B converges, or you need to make a conclusion, A sub k is the guy we're comparing to. So when you're looking at this limit, you're taking what you're given and you're taking the ratio of him with some comparison series. So the guy that you're trying to determine goes on top. Comparing to, that goes on bottom. Well, remember, you're just given some guy. Does that make sense? But this is how the conclusions are worded. Because it says like, hey, you're comparing to B sub k, and if B sub k, ha, cool, then yours, A sub k. It's easier to apply the direct comparison test, but still requires some comparison. Remember to rightly compare. Oof. It's more analytic, which is nice, because it requires more work and less just like trial and error, and hopefully we get it eventually. And if you guys notice, what type of problem specifically do I say to watch out for and to use limit comparison? Logs. LNs and logs. AP guys love LNs and logs. And the limit comparison test is probably the easiest way to go. Because you guys already know if there's an ln and an integral, ugh. Even though there was one in homework and it would have been very helpful for the next day in the quiz. But anyway, maybe the limit comparison test is the easiest way to go even when given logs. To you, because like, do I really need you to memorize log limit comparison? Not really. It's more of a, I think as you practice it, you'll get that. More analytic, and that's not a big deal. That's just me telling you you're going to get to play with math more. So it's up to you. I do think it's important that you know which one you're given. So you could be like, you're given A sub k, and you could put a box around. You're given this, concluding about him. I don't know. That little, like, this is easier to apply than a direct comparison test. I don't care if you put that in your endeavor card. It was just in the nice, pretty box that I stole. But everything above. Now, if you guys notice, hold on. Let's do parting C. P series. What's the sum look like? The sum of 1 over n to the p. That's the point, is a power, right? Now, hold on, wait. What do we know? If p is greater than 1. Converging. If p is not greater than 1, diverging. Okay, so that's important comparing powers to 1, right? Okay, parting C, PA, alternate, don't know that one. R, ratio root, don't know that one. T, telescoping. Does it telescope to something? Okay, forget telescoping, keep going. I, integral test. If the improper integral converges, there are 3 conditions, positive, continuous, decreasing. But if the integral converges, the series does. If the integral diverges, the series does. Okay, no special numbers in there, right? Just if it does, if it doesn't. Okay. P-A-R-T-I-N, nth term test. Ooh, the limit as n goes to infinity of the sequence does not equal 0. What do we know? Diverge. Does equal 0. Nothing. Geo. If we have a geo series, parting. Geo. R needs to be in between 1 and -1, or the absolute value needs to be less than 1. If my r is little, what do I know? If my r is little, sorry, if the magnitude of r is less than 1, if r is in between -1 and 1, what do I know? Converges to a sub 1 over 1 minus r. If r is greater than 1 or equal to, diverges. What's the number I'm comparing to here? Not ones. Zeros. Comparing to zeros, right? If L is greater than 0. Wait, if L is greater than 0, if there's an infinity, so does it mean all L must be a constant, right? So if the limit equals a constant, and the constant is greater than 0, then both series converge or diverge. But wait, what if he's a negative? He won't be. They're all only positive numbers. So if the limit is a constant, and the constant is greater than 0, what one does, the other does. This one is beautiful. Because I don't care, like direct comparison tests, I don't care bigger converging, smaller diverging. Whatever one does, the other does. I love that. Whatever one does, the other does. That's a great conclusion, which is why this is a great test. What if the limit equals 0? Oh, pause, pause, pause. If the limit equals 0, there's a huge idea behind this that isn't new for you guys. If the limit equals 0, who wins? Bottom. If bottom wins, couldn't we call him bigger? If bigger converges, then smaller converges. It's basically the direct comparison test, but kind of cheating because we're not really doing the whole bigger thing. But if the limit is 0, because this only works, both converge, both diverge, if greater than 0. If the limit is 0, aka the bottom wins, you just chose one that's bigger. Okay, well, as long as he converges, we're good. Pause. If the limit is infinity, who wins? If the limit's infinity, top wins. So he's smaller. If the smaller diverges, then we know divergence. What's the struggle? What if the limit is 0 and I'm comparing to a divergent? Nothing. What is infinity? I'm comparing to a convergent? Nothing. So the direct comparison test is kind of in the limit comparison test. In that, if the limit is greater than 0, I'm golden. I don't care. I'm just going to be smooth sailing. Who are you? He is too. But if I have a 0 or infinity, it only works sometimes. 0 only works for convergent. Infinity only works for comparing to divergent. Basically because of BCSD. Kind of? Okay? So let's go play. Oh man, if we were to have to do direct comparison, I mean, maybe I could take the 2 highest degrees and maybe I could compare to like 2 over n, but then I have to do a lot of terms to try to figure out when it starts and who's bigger and who's small. Forget it. Limit comparison test. Limit comparison test. Let's compare to... Why am I saying 2 over n? I don't know. Let's figure it out. But do you guys see where I got 2 over n from? I thought about my highest degrees. And what's 2n over n squared? Doesn't that reduce to 2 over n? Let's see if that helps. So what if I take the limit as n goes to infinity of 2n plus 1 all over n squared plus 2n plus 1. What's going to happen if I divide by that guy? I'm going to multiply by the reciprocal. Do you think maybe we can do a couple shortcuts here and there? So I'm dividing by the comparison, aka multiplying by the reciprocal. Why did I do this comparison? Because what's now true about my degrees? They're tied. What do I do if I'm going to infinity of tied degrees? Ratio of the leading coefficient. What do I end up with? Careful. 2n squared, and then you could have compared to 1 over n, either way. Why is this great? Whatever one does, the other does. Yes! So therefore I can... If I was really mean, I would make you talk about how both of them have positive terms, because both of them do. But either way, by the limit comparison test, since limit as n goes to infinity of A sub n over b sub n is equal to 1, which is greater than 0. And I need two ifs. I need that to be true and of 2 over n. What does 2 over n do? Diverge by? Good. P is equal to 1, which is not greater than 1. My series. What one does, the other does. The comparisons, we're always comparing two, and we need to know what the other guy is doing to make any conclusion. Does that make sense? So really, yes, we're practicing, solidifying, cementing the tests, hopefully. How about the next one? What are we going to compare to? Why am I going to compare to 1 over 2 to the n? Why am I going to say which converges by geo? What would I do? Great, I'm comparing, but what do I need to do? Put them over each other, take the limit, and then if the limit equals any non-zero constant, psh, golden. What one does, the other does. If the limit equals 0, am I still golden? Yes. Because I can make a conclusion if I have a convergent. But what if the limit equals infinity? This is convergent, I know nothing, I have to go try again. But the nice thing is, that will happen way less than it will with direct. Kiddos, you got to work on this homework, bring me questions tomorrow. Sound good? Okay. I'll finish off this guy, just so that we have them. Did I leave my microphone on? Did I turn them off? I don't know. Bye, guys. See you later. Bye. See you later, kid. Right here. Bye, James.